Hi, good morning, everyone. I'm Irina. Just in case you got the room wrong, this is about computer vision and deep learning. And give it a sec. Okay, so good morning. Right, so what's this talk about, actually? So let's say you are in a team who's building an app where they want to apply some special effects or filters to people. So they'll, for instance, on a phone, right? So you're taking a video of someone and you want fire to appear on top of them, or they hold their hand like this and they want some flame on top of their hand. Or maybe on the HoloLens because you're building some augmented reality experience. And they find out that, they'll be using Unity, right? And they find that there's this nice plugin from OpenCV, which is like the computer vision Swiss knife. There's a plugin for Unity. And the question is this enough? Is this good enough for us? Or maybe you're building an app where you want the user to be maybe scrolling through their Instagram feed, and they see some influencer wearing some nice clothes, and they want to know where exactly to buy them. So will computer vision take you far enough for that? Or maybe you join a lab that has been doing tumor segmentation for a while, and they're asking, does it make sense to drop traditional techniques and start introducing deep learning to carry on segmenting tumors better and better? So there are several different applications where the question is always, well, we already have a method here. Is it enough, or should we start building a deep learning pipeline to improve what we have? When does it make sense? This is, for instance, the kind of effects I was talking about. This would be the kind of thing that in a platform like a HoloLens or a phone, you would like to see. So you would be detecting someone, and fires and particles come out of their mouth, their hand, whatever. But we'll be looking at that case a bit later. So maybe you know this guy. At least if anyone's ever downloaded MNIST, the MNIST dataset, the name will be familiar. Otherwise, he's the founder of a Facebook AI research group. Let that soak in for a minute, because it's been 6 years since 2012. And you already have people talking about, how computer vision is outdated. And actually, yesterday at the social event, I don't know if he's in the room right now, but there was this person saying, well, I did some computer vision in university. And that was around 2012, and it's amazing how everything that I did is actually obsolete. Well, that may be a stretch. Because sure, deep learning has become a revolution, and many of the people deeply care about it. For instance, who cares about this? Well, people like me. So I'm a computer vision engineer, and I've been doing this, say, in applied research at INRIA, for anyone who knows that. I've been working in medtechs. I don't know why, but it makes me super happy to have done it in 3 different countries. And I've been doing it at startups, for consumer apps, and now at Siemens Mobility. So there's a whole ecosystem of people that really care about whether it's completely obsolete what we've been doing for the last 10 years, well, actually for the last 20 years, and whether we should all be just diving into deep learning, which is a fair question. But then the other question is, what exactly do we mean? So what is computer vision anyway? And that is up for debate, but this is kind of a description that I feel comfortable with. So computer vision would be an applied field where you take techniques from different areas. For instance, we want to extract features using image processing techniques, and with this, if you've ever heard about SIF descriptors or HOG, that's what I would be talking about. And we use machine learning techniques to extract meaning from those features, because the one gives us machine-friendly interpretations or representations of the images, and machine learning gives us techniques to understand what's going on with them, to detect things, to interpret them, to understand scenes, for instance. And one of those techniques inside machine learning is deep learning. It's just one more tool, and it's worth knowing the tools you have and when to apply them. So one huge difference between both fields is where exactly do you encode the domain knowledge. In the case of traditional computer vision, you will encode it in the code. That's where you know what you're going to be expecting, so you code already planning for those cases. Whereas in deep learning, for instance, you trust that you're choosing the right data set to train. That's why you want a huge, diverse data set to be ready for anything. And that's where you encode the domain knowledge you have. So in case you're in a hurry, spoiler alert, if you take one thing and one thing only, or actually two things from this talk, it's this. Always have a baseline, and we'll talk about what that baseline can be. And be sure to go through iterations of designing, tweaking, and evaluating both that baseline and your deep learning or newer computer vision approaches. So it's those two things that you need to remember. You need to know where you're starting from, that baseline, and you need to go through iterations where you're very careful about reproducibility, about knowing exactly what your hypothesis is and how exactly you're going to be measuring it. Right, so when? Yeah, the big question. And basically, it's about constraints. It's an eliminating game. You will receive your constraints that usually deal with data or the hardware you're going to be training on or deployment. And when you start looking at those constraints, hopefully, or sometimes not so unluckily, some of those approaches get discarded. So sometimes applying traditional techniques just isn't going to get you anywhere, and sometimes applying deep learning is just not feasible. So what kind of things are you going to be looking at? You always start with the data, right? This still is a data-driven approach. So what is your data? How complex is it? Are you going to be deploying your product in the wild? And in the wild I mean, if you're going to be detecting faces, are all your subjects like the woman here, nicely sitting in the middle of a frame, facing the camera, white background, extremely easy. Even if your baseline was just a dummy module that kept returning center of the frame as the center of the face, you did pretty well. And that would be a baseline, right? Just returning, center of the image, that's where the face is. Bam, finished, okay? But most of the times that's not going to be the case, especially if you're going to be using a product, in a bar with everything blurry, or for instance, with that fire dancer, where they're moving all over the place. Just trying to find something right in the middle of the frame, or with maybe just thresholding, maybe it won't help. Now, maybe some of you were here on Friday at the Luigi workshop, where this particular example was given, the bananas versus lemons. And he gave an excellent example of a baseline, where he was saying, okay, we can assume that lemons are going to be circles, right? So we apply a half transform, and we detect circles in an image. If there's a circle, it's a lemon. If it's not, it's a banana. Okay? And it takes you far enough. So what happens when you get wonky images, or when those lemons and those bananas appear all over the place? Well, that's closer to the definition of in the wild. And yet another problem is, how much data do you have, and what's its nature? Because if it's RGB, then, well, you're in luck, because after all, there's pre-trained models with ImageNet, so you won't, all that talk about needing millions and millions of images, well, it's kind of already been solved for you, because there's pre-trained models over those millions and millions of similar images. But as soon as your use case deviates from that one, if you're not dealing with RGB, or if you're RGB, it's still RGB, but it's a completely different field, maybe you will need some new data and increasing numbers of it. But the big question that you will always be asked is, okay, how much is enough? And for that, I'm sorry, but it depends. It depends on the complexity of your data. If you want rules of thumb, you can take a look at common data sets like ImageNet or Coco or Pascal. How many samples do you have from each class? And at the very least, you see that ImageNet it gives you 600 samples per class. Okay, is that good enough for you? I don't know. Is that too much? I don't know. Yesterday morning we had a talk about few-shot learning, where only a few samples were being used. So it also depends on the technique. But a good rule of thumb is, if you're really starting from a computer vision, a traditional approach, chances are you're not in a situation where you can handle very few samples in a deep learning field, in a deep learning approach. And two last considerations, it's hardware, not just for training, because for training, of course, you're going to be needing a GPU, but that can also be said for other machine learning approaches. It's always going to be quicker if you're using a GPU, right? So that's not the question. But it's mostly deployment, because where are you going to be deploying? Well, if you're going to be using AWS or GCP, if you're going to be deploying using TPUs, well, not that it might make sense, but you can, I guess. And that's not going to be a problem. You have limited resources. If you're going to be using a P3 instance, knock yourself out. But what if you want to deploy on a HoloLens or an HTC Vive or a phone or a camera? There's many smart cameras that only have CPUs. So what will you do then? Some huge models just won't fit there. And it's very easy, as an engineer or a researcher, it's really easy to go, okay, I did my survey, I know the best detector out there, and I'm just going to build it, and I'm done. Great, I've implemented it. And then whoever's going to deploy it goes, this doesn't fit in the memory. Dude, we only have a CPU, and we only have, or maybe I only have a phone, and we only have, I don't know, 50 megabytes of RAM available to us. That's not going to work. And more than that, what are you going to be using to deploy? What libraries? Because as much as TensorFlow is very flexible, you've got TensorFlow Lite for phones, you've got, and you can serve it on servers, of course. But if you want to use iPhones, or again, that HoloLens, and you want to deploy using, say, CoreML, well, as much as Onyx is a fantastic format, it's still ongoing work. So there are types of layers that are not supported. So what will you do then? You try to build your segmentation model, your detection model, whatever, and some of the layers that you're using just aren't there. So either you implement them yourself, or you're out of luck. So these are the kind of considerations you need to think about. Okay. So you got that in the back of your mind. But you thought, okay, I'm going to dive into it. So how does one start with this? And again, I'm going to go back to the idea of a baseline. You need to know where you're starting from, even if it's a really lousy baseline. Even if you say, well, random guess, or again, the example from before. I'm trying to detect a face. I'm going to say center of the frame is where the face is. Always, always center. And well, it's maybe a bad baseline, but it's one. And to get a baseline, actually, it's not just saying, okay, this approach is going to be my control. You also need to say, how am I going to make sure I'm doing something better? What number are you going to put onto it? What is your priority? Is it speed, or is it some form of accuracy? Define that accuracy, actually. Do you care about your false positives? Do you care more about your false negatives? What's in there? But more than that, you need to know, okay, in this domain or in this task that I'm going to implement, how do I know I'm doing better? And for that, you need to know the task. And the task is essentially the translation between what your user tells you they want and what machine learning or computer vision problem you're really solving. So let me give you a few examples if this isn't quite clear. These two applications seem very different, right? One of them is in the biomedical domain, where you'd be just telling someone if they have a melanoma or if they have a mole. Okay. The other can be a consumer app where they automatically tag your pictures before you upload them. Oh, hey, you've been taking a picture of a sunset, a beach, and you can then say, let's retrieve all of those images about beaches and sunsets. They're apparently very different, but under the hood, they are still just a classification problem. So you're probably going to be measuring them exactly the same way. Oops. And in this case, well, we won't be seeing the video. But in this case, oh, there you go. So let's say, for instance, these three examples, the one on top, Apple pays, Apple and other brands to be fair, tons and tons of money to be right there in the middle of many frames in films. That's their branding. It's called product placement. And of course, if they've paid a ton of money to a producer to include their products everywhere, they want to make sure. And years ago, they would have some person sitting through hours of footage, seeing how many minutes of the logo was in there. But you don't have to. You can just detect where the logo is. At the same time, you could be just detecting pedestrians to allow a car or a train or whatever to stop automatically without the driver having to do it. That's also detection. And the video you're seeing, or you've just seen, is another example of detection, where all you need to do is detect where the hand is and place the special effect on it. That's also detection. So it's three very different use cases, but under the hood, they are the same task. And likely, when you're measuring how well you're doing, you're going to be using the same metrics. Last example, segmentation. Tumor segmentation has nothing to do with, oh, hey, what clothes do I have here? Let's segment that, so I can then send that part of the image to some recognition system or to some query to retrieve things. They are very different use cases, apparently. But at the end of the day, you want the outline of a type. You want the outline of shirts, or you want the outline of a tumor. So again, same task under the hood, same ways of evaluating it, probably. Oops. So once you have your task, you choose a metric to evaluate how well you're doing. And these are just examples. And I'll go fairly quickly around this, but yeah, basically, you can, for instance, for things like classification, you can choose, you could say accuracy. Users or managers usually talk about accuracy, but they're usually not thinking, what do I care most about? So take your pick. Do you prefer to measure with F1? Do you prefer your precision, your recall? There's a ton of metrics out there. Choose one. Choose what you care for. Same thing applies with detection. In detection, you don't only want to label, you also want to know the rough location of that label, right? So you want a bounding box. So you could say, well, I want to know that overlap, or you could say, after that overlap has been met, then I want to know my precision and my recall. And with segmentation, you do need to measure that overlap. And another, for instance, if you're using tools like, this is important, if you want to choose tools that already give you some evaluations. For instance, if you Pascal VOC Challenge or Coco Challenge already give you access to code that evaluates models for you, or that evaluate predictions for you. So it makes perfect sense to not reinvent the wheel and make use of that. And there's no excuse really to say, well, it's just that I have to eyeball it, I have to look at it, because I've got no metric for it. Even GANs have metrics now. And I'll be sharing these slides, and there's tons of links in there. This is a link to a survey paper of metrics on GANs. So if that's what you're into, there's no excuse for you not to measure how well you're doing. Okay, so you've got your task, you've got your metric, and you're ready to design your baseline. So what is a baseline then? It can be actually anything. If you want to go for, random weights or reporting middle of the frame all the time, there's nothing there to stop you. But the whole idea is to have a fairly quick to implement, naive approach to make sure that you're not doing something stupid, investing weeks and weeks and weeks to get an approach to make another implementation that adds nothing. Because if you're already good, for instance, with the case of the bananas and lemons from Friday, if you're already getting way more precision than you need just by reporting that circles are lemons, why on earth would you want to do something more complicated? Just be done with it. Release, ship it. You're done in a week instead of a month. That's good. And that's the whole idea. So your first instinct should be to start simple. Have a fairly reasonable assumption of and implement it easily, hopefully. measure it because you've already chosen your metric, right? So measure that with that metric, keep that data set, that test data set constant, and that's where you'll be comparing yourself with. Okay. And last note about how we're going to be working, or how usually you'll probably be working. There will be a lot of assumptions, a lot of hypotheses, a lot of design, tweaking, and evaluating. Before you know it, you'll end up with tons and tons of experiments. How you track them is up to you. I don't know about you, but I've made my share of mistakes. And there's actually been also in PyData, so you should check the talks on Friday. There was one example, I'll get to that in a second. But how you track those experiments is up to you. You can go from very sophisticated and fantastic solutions, usually commercial, that track everything for you and start multiple experiments at the same time, and then have a database with all your models or all your approaches stacked up by that metric that you chose, down to, I'm just outputting custom named files and aggregating my metric results in a CSV, which is already the minimum you should be doing, really. Below that, you don't want to be there. It's painful. So anywhere in between, there's tons of options. And again, I really encourage you to take a look at, if you weren't here on Friday, I encourage you to take a look at the talk about polyaxon, because it does that for you, amongst other things. Otherwise, there's other free solutions like FGLab or ModelDB that are super helpful to keep track of your experiments. Right. Okay, so you've got your task, you've defined it, you know how to measure it, and you've actually decided upon a baseline that you're going to be comparing everything else against. Perfect. So let's try to apply this, tie it together in a couple of examples. And the first one can be, that application, a very simple application where you've got this on the phone. You've got a user going through their Instagram feed. They like what they see, take a snapshot, and expect to get links in return of where exactly to buy those clothes. So, is anyone here if there's computer vision people here, can you shout out what problem you're trying to solve under the hood? If it's detection, classification, or something else? It's image retrieval. It's plain old content-based image retrieval, really. You just want to see what's in the image and try to retrieve information from it. So the way you describe, you're going to be extracting information from that image, you're going to get a descriptor, and you're going to be sending it and getting something back, right? You're going to be finding similar images to what's in here. But of course, the devil is in the details, right? So you have, like we were saying at the beginning, you need to start with your constraints. So let's say in that team, your manager, your supervisor, your mentor, whatever, they tell you, look, we're going to be dealing with Instagram. We're going to be, we need to keep server costs down because, I don't know, we're at a university or you're a startup or you're on your own, and you really need to keep the costs down. So anything that you can run on a phone is already a world. And of course, you don't want to be missing hits because then you're losing money. So, and you also don't want to be giving money to, say, partners or non-partners, right? You just want money to go to whoever's selling the clothes that you have, that you carry, and you want money to go to the influencer that's been partnering with you. So, since this is a very simple case, it would be completely absurd, simple in the sense that, think about it, you're talking about Instagram. If you've partnered up with those influencers, you know fairly well what photo shoots have been going on, right? So getting something along the same lines is going to be a nicely constrained problem. So it would be absurd not to try a traditional technique because it runs extremely quickly on the phone and you save costs. You never need to actually go on the server and calculate things there. You don't need to do the image description there. You could also consider other options. But yeah, if you already have an F1 of 0.97 and say, for instance, for the sake of the argument, you receive the assignment of being above 0.95 in accuracy. Wouldn't this be enough? Would you really want to go through the whole setup of deep learning? Maybe you would. I don't know. In my case, I would say the learning would be to start simple, to avoid going through the hassle that is not really necessary or that will not give you extra value. And of course, take advantage of those constraints. So study the problem and see if you can get away with something simpler and maybe release something in 2 months instead of having to go through months and months of development and tweaking and evaluating and then finally shipping. Another example, a bit more complicated, I guess. So yeah, you saw, I think, the video at the beginning. Let's say you want to apply some special effects on someone, and you're going to be doing it on a phone, or in this case, is a HoloLens. So again, you're going to have some some huge. Oops. There we go. You're going to have some constraints, and it pays to look at them and be mindful of what you're going to be deploying. Or, for instance, you have a case where this is fairly in the wild, where you have tons and tons of different sizes, people really far away, so it's not anymore a selfie where, yeah, I'm taking a picture and I'm right here, right? Even reporting center of the frame would also already be a good approach. So if you want to apply, say, a filter on all of those faces, you better have a really nice model that can see really far away and really small faces. So again, you start with the constraints. That's unfortunate. Let's say, for the sake of the argument, that those squares are actually happy faces. Sorry about that. So those are happy faces. So yeah, basically you take a look at the constraints, and something is going to be running on the phone. So deep neural networks, it can be done, but it will take some suffering. Whereas usual traditional techniques are really nice to run. You need to be doing this in real time. If you're going to be applying filters or special effects, you're probably going to have a Unity layer on top. So it's not just being on real time, you do need to do better than that. So yeah, again, CNNs might have a bit of a problem. Traditional techniques, we'll see. Usually it should be okay, at least just the speed itself should be okay. With data in the wild, so how are you going to be applying it? In a nicely constrained case where people are, with a white background and staring right there, or are people going to be using your product while maybe moving around and in a bar, low light, facing away, just maybe running, being 10 meters away, or like in that group selfie, again, you might have people that whose faces are really, really tiny. That's kind of the definition of in the wild. You don't really know what to expect. And their traditional techniques, I don't know. Whereas CNNs should, depending on the data you choose to train, should be okay. And for both of them, since you're going to be dealing with RGB, then that's not really a constraint. You're free to use whichever approach. So, what kind of task are you doing here? We've been talking a lot about detectors. So yeah, spoiler, it is a detection problem where you want to know the location and you want to know the rough size of your target to be applying things like, that fire effect. So we're going to be using precision. What about the baseline? Well, since there's already an OpenCV plugin for Unity, and since, after all, computer vision has been doing face and people detection for a long, long time, and it has been state-of-the-art until fairly recently, it would be a bit dumb not to try it out, I guess. It's right there. It should be easy to set up, right? So let's say you go with that. And you design your baseline. You say, well, I'm going to be using cascade detectors, for instance. And I'm going to be, and I know I've got the profile, and I've got my front, the ones specialized on frontals, and I've got the ones specialized in heads and shoulders. So I'm going to try all of that. I'm going to tweak them, not too long, but enough to have it reasonable. And I'll go with that. Let's see. And after some little tweaking and deploying it, You choose your data set, you measure, and yeah, maybe not. Because after all, your test data was trying to be realistic. So you had people at very different distances and doing all sorts of weird things, and yeah, maybe not. Plus, it wasn't so fast anyway. If you want to do real time, you should really be aiming at something at least 25 FPS, and if you have other layers on top, you should really be aiming at something like 30, 40. So, yeah, not going to work. So again, back to the blackboard, and you're going to have to think about your constraints. So again, those black boxes are actually smiley faces, and we were suffering about deploying on a phone. We were suffering about deploying and being able to run this in real time, and we're not so concerned about data. So what do you do when your main concern is actually the hardware and your specs? I'm not going to go into too much detail here. I guess I'm going to be clickbaiting you. There's a talk last year about this exact case and what we did when we saw that computer vision was failing us and we had to apply deep learning. So this is a real case that you can check from PyData 2017. But basically what you do is, okay, let's look for a detection architecture that is light and fast and has a fairly good accuracy. And since you have your constraints and you need how fast it has to be, and you know how much memory you need to use, you can already filter out quite a few architectures, right? So you can think of just implementing those. So again, the cycle of designing, tweaking the hell out of it, and evaluating and comparing against that baseline. And you could maybe end up with something like this. This is ballpark figures, but it's fairly reasonable, where you would have measured your speed because you have a very hard constraint in speed, and you're also measuring your average precision because you care about how the quality of your predictions, right? And it turns out that it's much, much better than your baseline. So definitely you still need to tweak, and you want to be deploying and making a whole continuous delivery system around that approach, the deep learning approach, not the computer vision. But you wouldn't have known, or you wouldn't have been sure if you hadn't started off with a baseline. And I'd just like to make a final note. I've got a couple of minutes left. So just about how these things usually go, because it's not an exact science. So you always have that doubt. Should we go traditional computer vision? Should we go deep learning? As time goes by, probably your baseline will already be something like a pre-trained model, right? Eventually, those concerns about hardware will not make much sense because we're not going to be so limited. Formats and deployment libraries will not have so many constraints. You will be able to deploy anything that you're able to train. So it's just this transition time where you need to be very mindful. But today, we're still in a situation where you need to think, okay, how am I going to use my resources? How much time do I devote into working on that baseline that might take me far enough or not? I'm not sure. Should I already start working on that deep learning approach? So first, you're probably going to want most people working on that baseline that you hope will be enough and you hope is going to be the only solution. And at the same time have maybe someone still looking into doing survey work, looking at papers, seeing what's out there, seeing what people have already been able to deploy. At some point, you really want to define what metrics you're going to be using, how you're going to be making your decision, what metric, what data set, what's your test data going to be, and making sure it's extremely similar or as similar as you can get to your real use case. And at some point in time, hopefully very quickly, you're going to confront both of them. You're going to be measuring your baseline. You're going to be measuring a first naive approach of a deep learning solution. And if it happens like in the example before, you realize that no matter how much you tweak that computer vision approach, it's not going to be good enough. So you're better off cutting that and moving everyone to work on the deep learning approach. So yeah, recapping everything in a nutshell. What I would do starting right now, is always be mindful of constraints. I would always be thinking about, okay, am I being asked really? Can I get away with something simple? It's always about getting away with things, right? It's about how I want to be things very simple, but not so simple that nobody wants to use it. I don't want to waste time getting that extra 0.1% like in the papers, but I do want things to be good enough for people to use. So what are my real constraints? Do I have to be deploying in real time? Do I have to be? Do I have to support any imaginable case? Or do I really know that under the hood, people are going to be using my product in a really nicely contained space where I don't need to plan for everything? Like in that Instagram case, is my problem really in the wild? Do I have to support any kind of picture anywhere? Or am I really in a nice little box where I can get away with something nice, simple, and fun to use? Second step would be, okay, since I know the task that I know my constraints, now what task do I need to solve? What machine learning or computer vision problem am I really solving? Is it classification? Is it image retrieval? Is it tracking? What is it? And what metrics do people use to measure this? And last of all, well, at least last of the preparation part, decide on a baseline, get it measured, and yeah, that's a good start. So yeah, thank you. And if you've got any comments or you want to tell me how you guys do it, keep in touch.
Thank you, Irina. And we will be taking questions right after this short announcement. If any of you do leave, take your empty cups. And where's our next speaker? Okay, great. Questions? Yes, please.
Hello, and thank you for the presentation. I have a question about the baseline and the the model that probably complex model that you want to create, right? Imagine you create a baseline very simple, very fast with 95%, right? How is it possible to estimate the complex model accuracy before you implement it?
Right, you wouldn't estimate it really. You would, if the baseline is already matching your expectations, you can stop there. Not in research. In research, of course, you want to go as far as you possibly can. But if you are told we need to deliver to get the next investment round in a month, and your baseline is already good enough, you ship the baseline. And you don't think.
But about the goodness of the accuracy, right? Like 95, 90. There is no such as exact answer for that, right? It depends on the complexity of your model or your problem, right?
Sure. If you want to later on work on it because you get additional constraints and you want to start working on that other, then you report that. But that's after you've built it because you want to try it out, because you're not very sure, because you think, right, that was good for this first release, but it's not going to take us 2 years. Okay. So, but at the very beginning, if you really, so it depends on time constraints, right? If you really need to ship something and the baseline is already good enough, you ship that. If not, you carry on working and you have to push the deadline. But the thing is that is ship something that is good enough, and then you don't really estimate. You don't think about it. You start thinking about it when you realize that your baseline is not good enough.
Thank you.
More questions? I have one.
So you mentioned two things. One is the importance of measuring, and in the beginning, kind of the lack of labeled data that we usually face, which makes it hard to measure. How do you reconcile the two? So if we lack labeled data, it's hard to measure on things, right?
Yeah. It is hard. So when you've got you're talking about the very limited. So when you've got very limited data, how are you even going to divide that so that you can train on something and test on something? There's different schools. I personally prefer to save as much as I can for testing and try to augment the data I have for training. At least in images, I'm not sure about other disciplines. In images, it's fairly easy, or at least it's feasible, to augment the data that you have to get a proper training set and then reserve as much as you can from the real data for your evaluation. So that's what I usually do. I'm not sure if that's the best approach, but yeah, it works for me.
Okay, thank you. Last question? All right, so go to your next rooms. Thank you. Thank you, Irina.
Thanks.